Hey everyone, this is Albertina here again from Cornerstone Laser. I'm taking a break from my normal Lasers for Beginners series, and I'm here to teach you today how to make a DIY sugar rocket. And the intent is eventually that I'll be using my laser to cut some fins and try out some various fin designs for a couple of these rockets. But before I get to that point, I thought I'd actually teach you how to make the rocket engine itself. Now bearing in mind again, this is just the engine, not necessarily the rocket, but I thought that I really want to teach you how to make the engine first, and so that you can test that and make sure that that works before you actually put it into the rocket. So today's episode is just going about how to do that. At the end of the episode, there's also a couple of videos where some mistakes were made. I learned a lot of lessons, bearing in mind that it's highly unlikely it will probably work the first time, but it's got a really high predictability if you follow all of the instructions. So if you've been trying this and struggling with a couple of things, I would recommend that you stay to the or scroll to the end of the video, and there'll be a couple of options there where you can have a look at some things that I really struggled with and fixes that I found to do that. Alright, so effectively, as the name implies, it's a sugar rocket, so you're basically mixing potassium nitrate with caster sugar. The finer these components are, the better, and you're effectively putting that in a PVC tube, and then you're putting clay plugs on either end. So just on the table here in front of me, I've got a couple of the ingredients for that. The first one is the clay. So this is, if you can get the cheapest kitty litter that you can find, that's actually the best approach for this. And you really want to look for something that's base bentonite clay with no additives as far as possible. This particular one that I got is the cheapest one that I could find. It does have a little bit of baking soda in it, which actually retards the burning of a rocket to a certain extent, but because we're not actually, the rocket's not burning the clay per se, it's burning the white powder material, it shouldn't make much of a difference. But the closer you can get to just straight bentonite clay, the better. What you would also want to do is get some potassium nitrate. So in this case, I just bought potassium nitrate online. I know in America you can get a product called stump remover, and that's also effectively just potassium nitrate. And you can get caster sugar. That you can just get it in the supermarket. So the reason you want to use caster sugar is that it's a really fine form of sugar. As you're probably aware, the finer the component for a chemical reaction, the more quicker the reaction, because you've got a greater surface area. And so in this case, what's really important is you make everything as fine as possible, and that just gives us the better reaction and the best results. What I've also got here is an old blender, and the reason for that is to make these components as fine as possible. Generally, the caster sugar itself is fine. The potassium nitrate, even though it has fine crystals, we want to make that again as fine as possible. And the kitty litter comes in a large granule, and I found from trial and error that not blending the granules doesn't give me the best results. The plugs just tend to blow out, and so what I found is actually blending them and making them as fine a powder as possible, so they're compact as well as possible, is giving me the best results. Now again, you don't want to contaminate your powder with your clay, because that will obviously retard your combustion and your rockets are not going to work. So when you do use a blender, obviously don't use one that you need to use in your kitchen or whatever. Use a disposable one or one that you could damage, but try to use separate containers. So I'm actually quite fortunate that this one has two separate containers, and the one I blend the kitty litter and the other one I blend the potassium nitrate. So it's really important that you don't blend potassium nitrate and sugar already in your rocket mixture, because the friction could actually set it alight, and that's very dangerous. So always only blend the potassium nitrate. The other thing that you would want to do is effectively get a 5-inch piece of conduit. So this is a 25mm outer diameter piece of conduit, and this is just standard electrical conduit. You can get it at any home improvement store like a Bunnings, Mitre 10, or anything like that. This particular length is a 5-inch. That's pretty common for your first revision of the rocket. If you wanted to in future make it more powerful, you could just increase the length and put more of the rocket powder inside it. Then you also need a 10-inch 20mm dowel, and then it just needs to be able to fit snugly into your conduit, and you would actually use this to compact all of the components in various phases, which I'll show you later in the video. The other thing you'd need is a dowel rod. I've already used this one, but effectively you'd need to make a tail, because it's not a rocket yet. It's just a rocket engine. Firing off the rocket engine, which would effectively just be this tube, will make it highly unstable, and it's not going to fly straight. So effectively it's exactly like a kite. You would need to attach a tail to it. What the tail does is it keeps it pointing straight up, and then it will actually fly in a nice, hopefully a straight line. There's various Other methods you could use, I found that this dowel is actually pretty good. I think it's a 5 or a 6 millimeter dowel. You can maybe go a little bit thinner. What you want to do is try and not make it heavy, but you want it fairly long, and that creates a very stable bending moment, or moment to keep it actually straight, firing straight up in the air. In the future, when we do attach this to a rocket itself, you won't need that anymore, because the rocket will have a nose cone and will have fins, so the air flowing over the rocket itself will actually keep it stable. So let's get started. Right, so the first thing you want to do is use the blender to blend your various components. I do this in separate containers. Here I'm first blending the kitty litter, and the intent is obviously to make these as fine as possible. You can also turn the blender to the side to reduce the load on the motor, and make sure you don't burn it out. And try not to fill the container completely, again, just so that you reduce the loading on the motor. The next step is to mix your potassium nitrate with caster sugar. So you want to mix 65 grams of potassium nitrate with 35 grams of caster sugar. So take the container that you're going to use and put it on your scale. Obviously a digital scale is preferred, but in this case I don't have one. I've only got a mechanical scale, so that'll have to do, but it works well enough anyway. So zero off the scale when you put your container on it, and then mix in the various components. It's important to do this by weight and not by volume. I've done it by volume in the past and that doesn't work. This mixture, about 100 grams of this powder will make 3 to 4 of these rockets, but because you obviously want to test some of them, it's best, I would recommend, to make a double batch, so you've got enough to test and enough capacity to make additional rockets if you so choose. The next step then is to mix it up completely by shaking the container. It's best that you don't, the first time you do this in the container, you do it actually outside, because you don't want to build up too much static inside it. And if that creates a spark, it could actually set this rocket fuel alight in your hand. So you'd want to shake it for 2 to 3 minutes to get a good mix. Once you've got a good mix, I would recommend that you test it. I found that what you want to see is a really aggressive flame with a residue at the end, which is like a black charcoal and very brittle mixture. And that seems to give me the best results. The next step is to put the markings on the dowel that you use to compact the various components. So it'll be a 10-inch dowel for the 5-inch rocket, and the last 5 inches or 127 millimeters will be the bit that you hold as a handle when you're doing the compaction. Then working our way from left to right, the first 19 millimeters is a gap. It'll allow the dowel to stay in place when you're compacting the final layer. Then it will be a clay plug of 19 millimeters thick. Then the rocket powder or the rocket fuel, that will be 70 millimeters thick. You can increase that if you wanted to make a more powerful rocket. And the final clay plug would also be 19 millimeters thick. When you've got everything set up, I would do this work outside on a hard surface. And basically you could use funnels for the various components, or for the 2 components, the clay and the rocket fuel, but I wouldn't use the same funnel for both, because obviously you don't want to put clay powder residue in your rocket fuel mix, because that will retard your reaction. So I've got 2 separate funnels. If you don't have funnels that you could damage or disposable, you can roll up paper sheets into conical shapes. So basically the first one is your clay layer. That will be the first 90 millimeter clay layer, and you basically compact it down with the hammer until it reaches your top line. Once that's adequately compacted, then you would do the same with the rocket fuel until you get your rocket fuel layer, and then you do a final layer of clay until all that is completed. The next step is to drill a hole in the bottom of the rocket, and that is to install the fuse. The hole needs to go through the bottom clay plug and through the rocket fuel, but stop at the bottom of the top clay plug and not drill through it. I found the best way to do this is to drill through the bottom clay plug by hand, as shown here, and then to do the remainder of the hole with an extended drill bit on an electric drill, because that just goes a lot faster. I've also found that it's best to pull out the drill bit intermittently and clean up the flutes, because as they block up, it becomes more and more resistant and it gets harder and harder to do this. The best you can get it in the center of the rocket, the better, but I found that even if it's a little bit skewed, it doesn't really make a difference on performance. Then to install your cannon fuse, I make a barb on the end. I just bend the tip over and then insert it into the rocket as far as it will go, and then cut off an appropriate length at the end to give you sufficient time to light it and get to a safe distance. Then I attach the rocket to the dowels with duct tape as sturdily as possible. I found that if this is not properly attached, the dowel tends to flounder around when it flies, and it creates some flight instability. I've also used similar pieces of conduit attached to a larger dowel as a launch pad. Seems to work quite well.